No.
Previous one,
Yes.
this one,
No, sir.
this one.
Yes, sir. This one. This, sir.
Okay, all right. That means slide 23. We start with here. Okay, no problem. So look at this, Mr. Abir. I believe you can hear my voice, right? Abir, are you listening to me?
Yes, sir. I listen.
Okay, all right. Did you miss from here or where?
Sir, after find out the segment and offset, there will be some theory you discuss. But
Okay,
Sir,
so
after this
this
slide,
is this is the last slide as I learned from your the fellow
no,
students.
sir. Not this.
I have
I think
written
slide number
that
24. Yes, sir. No, sir.
but
yes, sir,
I
this
took
slide.
the note. It is up to the slide 26. No problem. It's fine. Okay, so we are going to start from there. So it is, if you look at this picture, I will take you back to this slide again. So how many resistors we have? Three sort of resistors, right? Data resistor, address resistors, and status resistors. Does it make sense? So for the address resistors, you can divide it in two ways: segment, index, and pointer. So all together, segment resistor, index resistors, and point resistors, all together you are considering as a address resistors. Does it make sense? So now here, if we go to the slide number 24, before 24, we are learning all about the segment resistors. Does it make sense? Segment resistors, actually, it is part of the memory. The address resistors. Still remaining index resistors and pointer resistors. So we have to know actually what is the purpose of the index resistors and what is the purpose of the pointer resistors. Okay, and how all these resistors are working with the segment resistors. Does it make sense? Because all together you are going to say this is the address resistor, right? When you are combining segment resistor, pointer resistors, and index resistors, three together, you are going to consider or address as a address resistors. Does it make sense? So far we finished about the segment resistor. That means you are learning how you can calculate the physical address, right? If we want to calculate the physical address, we need the logical address. What is logical address? Logical address is the combination of segment and offset. What is segment? Segment is the part of the memory. Each and every segment has a segment, you are saying it's a block of the memory actually. Segment, as I'm saying the part, more officially or formally, you can say each and every segment is a block into a memory. Okay, and this block should have a maximum size. Okay, and this maximum size is going to be like 2 power 16. Okay, and this segment and offset you are using to calculate the physical address. What is the formula? I believe you can remember. Physical address equal
segment multiply 10
Segment multiply 10 plus
10 plus offset.
So yes, so that is the 20 bits physical address you are calculating using that. If you know the formula, from this formula, you see, you can find the physical address, you can find the segment, you can find the offset. If I give you two values, you can find another value. Is that clear from the previous day? That
Yes,
was
sir.
our last discussion, right? So today we are going to see another two part of the address register that is known as a pointer and index resistors. Okay, so look at here. What about these? You see, basically you are going to see, look at this: stack pointer, base pointer, source index, and destination index normally point to the memory location. Normally point to the memory location. So what is the purpose of the stack pointer? As I told you in the previous day, maybe, that stack pointer, you know the concept of the stack, right? Last in, first out.
Last in, first out.
Does it make
Before.
sense? So stack pointer, so there is a resistor name like stack pointer, and how and which purpose microprocessor use this stack pointer. So when microprocessor dealing with the stack segment, then microprocessor using this stack pointer. So stack segment and stack pointer, there is a relationship. Okay, there is a relationship. So look at this, when microprocessor using the stack segment, or when microprocessor accessing the stack segment, that time stack pointer is going to be activated, or stack pointer is going to be used by the 8086 processor, or by the machine, you can say. Is that clear? So, and that is the reason you are saying it is conjunction. This stack pointer is conjunction, is like bonded with the stack segment. Is that clear?
Yes, sir.
Yes, sir.
Okay. Now, what is the
Sir,
purpose of the
what
base
does it
pointer?
mean, sir?
Sorry?
Sir, what does it mean, sir? SS.
What does it mean?
Stack
SS.
segment.
Take segment.
Okay, thank you so much for helping me by giving
Sir,
the
please make it
full
full
meaning.
screen.
Yes, please, thank you. So now you can have a look, the base pointer. Actually, this is another pointer that is also used by the microprocessor. And we ultimately know all these stack base both are inside the address, right? So look at this base pointer. So base pointer, now you know the stack segment. You know that some data into the stack segment, right? So when you microprocessor going to get some data from the stack segment, then microprocessor use the base pointer. You see, this is the base pointer. So base pointer resistor is used primarily to access data on the stack. And we know where we can see the stack. Stack, it is in the stack, the stack of stack segment, right? So in the stack segment, as that's why I told you what is segment, what is offset. You see, just to understand this concept as well. If you don't know what is a stack, what is the stack and what is the segment. So when the data is storing into the segment, there should be some method, some way to store and way to take out, right? So if you know the stack, you know what is the procedure of the stack and what microprocessor follow, right? So it is following by the stack, that will last in, fast out, and that way. So if you are inserting like 1, 2, 3, 4 into the memory, then it will come out like 4, 5. What is that? 5, 4, 3,
5, 4, 3, 2,
1.
1.
Like that way, reverse way. Okay. So this is the purpose for the base pointer, and at the last point, they are saying for the base pointer that it is unlike the stack pointer. Why they are saying the unlike the stack pointer? So that means the function of the base pointer and stack pointer is different. Base pointer is using by the microprocessor just in order to access the data from the stack. But you should understand that stack means what? Definitely this is stack inside the memory, right? From the memory, you are just getting the data by using the base pointer. Is that clear? So microprocessor using that sort of pointers, the stack pointers and base pointer, just to get the access from the memory. That is the main summary. Okay, if microprocessor want to access the data from the memory, then microprocessor need to use the stack segment, the stack pointer, as well as the base pointer. Is that clear? So what is the main purpose for the base pointer? Microprocessor use the base pointer to
Access the data from the stack.
to retrieve the data or to access the data from the stack. That is the main function of the base pointer. Is that clear? Say for example, I can select 5 students. Student X, student Y, student Z, student A and B. I can give you, okay, student A only can listen. Student A cannot say anything. Student X can do a particular job. Student Y can do the particular job, right? So I'm just using particular student for doing the particular job. Does it make sense? Say for example, the student who is listening, I'm not telling him to writing down something. He will always be busy with the listening. Right. Similarly, microprocessor using some pointers in order to get the access the data into the memory. So all these pointers and the index registers using the microprocessor just to have an access into the data. Okay, and where will be the data? Data will be the stack and stack into the memory, right? So you can have a look when we are going to, as I said, that this kind of stack, the application of the stack, you can see when we are practicing with the shifting and rotation, we can understand. Okay, all right. Is that clear to everyone?
Yes, sir.
Yes,
Okay,
sir.
now we are moving to the another one, source and destination. Source means starting and destination means you are stopping somewhere. Does it make sense? Like segment, we know the segment, right? Each and every segment has a starting physical address and each and every segment has ending physical address. Do you agree with me or not? Did we practice that one? Did we find the starting and ending segment, the physical address of segment? Can you remember?
Yes, sir.
Every segment has a starting. Can you remember the picture I showed you, the figure? Every segment has a starting and segment always start with the 0 at the end. Can you remember?
Yes, sir.
Sir.
Yes. Okay. You are taking longer time to recall that one actually. Anyway, no problem. It is good that at least you can recall that there is a segment. We learned something. We practiced something. That segment and every segment is starting. Having with starting physical address and ending physical address. Okay. So that is the main concern we have to make sure. Now look at the source index. As I said, source means somewhere you are starting. Source index register is used to point to the memory, location in the data segment address by data segment. So source index basically indicate where is the starting of a particular segment from where you can get the data. Does it make sense? Look at here. Register is used to point to the memory location in the data segment. Used to point to the memory location. So you have the memory location. Inside the memory, what we can see inside the memory? Inside the memory, we have a segment and offset, right? Am I right or wrong?
Yes, sir.
And every segment has a starting that you are indicating by the source index. So always microprocessor know that where is the starting of the segment that is using by the source index. Is that clear?
Yes, sir.
Okay, and the destination, it is just opposite of the source index. That means microprocessor try to understand where would be the ending part for that one, destination. Where would be the ending for this segment? You see, the DI, destination index, source index and destination index registers perform the same functions as source index. Similar function, but one is starting, another one is the ending. Is that clear?
Yes, sir.
And instruction pointer, that is another, as I said, index and pointer and segment together address register, right? So we have seen the pointer and index. There is another pointer that's called the instruction pointer. So we need the instruction pointer. I said that means microprocessor using the instruction pointer for what purpose? You know, yes, can you just have a look the text that they are giving to us here? To access the instruction, 8086 processor use the resistor. One resistor is the code segment, another resistor is IP, that is instruction pointer. Did you get the idea? that how microprocessor using to access the instruction. Microprocessor use the code segment and two resistor. One resistor is instruction, pointer. Another resistor is code segment when microprocessor accessing the instruction. Now, what is the purpose of the code segment? Look at these code segment resistors actually responsible or for containing the segment number. Can you remember how look like the segment number? Did you see the segment last day?
Yes, sir.
Students, are you listening to me?
Yes, sir.
Yes, sir.
So
Yes,
why you are responding? Taking to response to take you are taking longer time. Okay, so you learned the segment, right? That means we are finding the segment, we are finding the offset, right? So look at here. So code segment resistor contain the segment number of the next instruction, contain the segment of the next instruction. Say for example, microprocessor working with the one instruction. So which instruction is coming to the microprocessor for execution, that segment's number will be stored into the code segment. Next instruction, you should understand not the current segment number. Does it make sense?
Yes, sir.
Is that clear?
Yes, sir.
Sir.
Yes. And the IP contain the
Offset.
offset. So segment plus offset together we are going to say the logical address. So you should know that instruction pointer basically responsible for keeping the what offset into the memory. Is that clear? And code segment actually containing or holding the segment number of the next instruction that is going to be processed by the microprocessor. So during the Viva or in exam, I may ask you some questions about this. So please try to make things clear. What is the purpose of the code segment? What is the main function of the instruction pointer? What is the main function of the source index? What is the main function of the destination index? Like this. Is that clear, guys?
Yes, sir.
So, and when you are completing all these source index and like a pointer, that means you are completing the address registers. Okay, and then we are going to have a look at this, the flag register, the last part, the status registers. Okay, the flag registers you are just referring as a status registers. So every time, as I mentioned you previous day, every time microprocessor when an instruction is executed by the microprocessor, every time microprocessor get the updated status. Okay, so look at this, you can divide it, you see, to indicate the status of the microprocessor. Whenever microprocessor getting some status, that status coming through the flag registers. And you can categorize these flag registers. One is the status flag registers and the other category is the control flag registers. Okay, so all these two categories of flag registers we are even going to see in the next chapter, maybe in chapter 6, I believe. Okay, now what is that? These two bullet points actually representing the function of the status flag and function of the control flag. Okay, so reflect the status flag. So status flags are basically involved with the result of an instruction. Or I can simplify in another way that all the status flags are related with the result of an instruction. That means whatever status are going to be passed to the or going to be transferred to the microprocessor, the status actually coming from the result of an instruction. Does it make sense? And that is, you see, the result of an instruction executed by the processor, for instance, 0 flag. You see, if the result is 0, the status will be one kind of status. If the result is 1, that means there will be another kind of status to the microprocessor. Is that clear? But you should just keep in your mind that status flags always related with the result of an instruction. That's it. And we will match up this one when we are doing some example in the next chapter. Okay, but you should understand, you should remember today's concept. You have to recall on that day when we are doing some calculation and how it is related with the result. Okay, look at this, reflect the result. So when you are doing some addition, when you are doing some addition and subtraction, are you getting some result?
Yes, sir.
Okay, so if you are getting some result based, guys, whose microphone is turned on?
Then Kamrul.
Okay, I muted for all. All right, so we know that we are getting sometimes result, right? So based on that result, the status is changing or transferring to the microprocessor. And the last one, the control flags. Basically, control flags is related or activating or deactivating, activating or inactivating, I should say, certain operation of the processor. For instance, interrupt flag. So the control flag always enabling and disabling, enable and disable, you know, active, inactive, maybe either 0 or 1. Like these certain operations, you are saying not for the every operation, for some settings, for some very particular operations of the processor. So that means these control flags are not interfering all kind of interactions, I mean the instructions. Control flags are working only for some particular operations, certain, very certain operations of the processor. What kind of certain operation? It may be, example can be interrupt flag. So the result of the interrupt flag can be enable and disable the activities of the microprocessor, or the status can be enable or disable. So microprocessor can understand, okay, this time it's enable, so it can be processed, or it the CPU should give the time, you know, the cycle. Okay, when an instruction is executing by microprocessor, just CPU microprocessor giving the time for that particular, that is the concept of the process. I believe those who you are taking the operating system, or maybe, yes, particularly from the operating system, you can learn the process, what is called the process. Okay. All right. So this is about the status flag and control flag. Is that clear? Just try to keep in your mind that status flags are related with the result of the arithmetic operations. Look at this, reflect on the result of an instruction. So result of some operations. Okay. Either particularly we are considering the arithmetic operation. And as I said, you are going to see the example. Okay. All right. Next, we are going to see, guys, any questions from here? Any
Sir,
query? Yes.
sir, for the plug resistor, already there have set status register. Why they are divided in status plug and.
Sorry, your voice not clear to me, Tunni Sharkar. Can you repeat your question, please?
Sir, before said that for the plug resistor is the meaning of another status. Why all divide with two stat plug and control plug, sir?
Okay, you are asking why status plugs, I mean the flag resistors are dividing in two categories, because according to the function, at the very beginning we learned, right, that resistors are categorizing according to the function of the resistors. So some flag resistors has different functions, and that's are related with the status flags. Okay, so status flags always has the function that is not similar with the control flags. Does it make sense? That's why you are categorizing in two different way according to the function of the resistors. Okay, is that clear?
Okay, sir.
Okay, all right. And now we are going to have a look. You see, these are the very basic things.
Sir,
Yes, please.
what does control flags do?
What does control flag do? Someone, can you help me? What does control flag do? Anyone?
Sir,
Did you
actually,
understand? Yes.
yes, sir. Actually, control flag doing some certain operation like enable or disable some operation, or active or inactive some operation.
Yes, but not all operations, some particular operation, like kind of interrupt. Say for example, when your computer is going to be hang, when you are giving many, what should I say, like unaccepted command to the computer will be hanged up, right? Have you faced that situation? You cannot do anything. Either, unless you are restarting your computer. So what kind of, it is a kind of interrupt, right? So microprocessor getting some interrupt message, and that is actually passing through the control flag resistors. Is that clear, Firdausi Akhtar?
Yes, sir.
Okay, so the control flag resistors has very certain and particular operation that sometimes make it enable or disable some operations. Okay. All right. Now, what is the concept of operating system? Can you tell me? What is the concept of operating system? Who can tell me?
It's a medium between
It's a
hardware
medium
and software.
between hardware and software. So operating system.
One of the computer system, sir.
Sorry.
Between resistor and software, sir.
Sir, operating system.
One after another. Not both student or three student together.
Sir.
First of all, you can raise up your hand. I can tell you who can tell. Okay. Yes, Ajad Hassan Jim, tell your answer or understanding.
So operating system is a system software that manages the computer hardware, software resources, and provide common service from the computer program.
Okay, and Husniara, do you agree with the Jim?
Operating system is a system software that provide an interface. By using that, a user can execute programs in a convenient and efficient manner. Basically, it is like an interface that helps the user to connect with the application software.
Okay, all right. Yes, I believe others, you are listening. What is the concept of the operating system, right? Okay, now we are going to, yes, Jim and Husniara, thank you so much for giving your understanding. Yes, you are right. Operating system is a kind of intermediary system, and that intermediary system actually create a bridge or link in between the user of a computer and computer hardware. Does it make sense? As a user, can we directly communicate with the hardware?
No, sir.
No. Operating system helping us, making our lives so comfortable to communicate with the hardware system of the computer system. And as you mentioned, Jim mentioned that it gives an instruction to the hardware how to do or how to perform the work, right? So basically, you are giving some instruction as a user. Operating system carry your instruction and execute it with the help of the hardware. So hardware need to understand what its users saying, right? And that job is making or understandable to the hardware, that is the operating system. You can also say it is a kind of system software or collection of program, right? So that is the concept of the operating system, but not that's the everything. We are going to have a look at meet all 3 students are waiting to join. Okay. Yes, you are going to see the operating system to coordinate the operations of all the devices that make up the computer system. Yes, operating system, as I said, all the devices, all the hardware devices, basically, it can coordinate. And definitely, if you want to run some application software, you have to have the system software, which is known as the operating system. Okay, and look at these some functions they are saying about the operating system. So, but one thing you have to understand, the routine. The routine means nothing but it's like some process, some activities, some series of activities you are executing one after another to execute an instruction. That's you are representing as a routine. Okay, and they are coming with a operating system that is known as very early stage operating system, which is known as a DOS, disk operating system. Do you know what is the difference between DOS and Windows? Anyone? Do you know what is the
Yes, sir.
difference between disk and the DOS and Windows?
So in I think we user have to use command prompt to give the instruction, and but
for the DOS,
for the DOS,
yeah,
Windows
yes.
we have the graphical user interface.
Absolutely right. You see, the DOS, if you want to do something with the DOS, your life is going to be so difficult. Even, you see, nowadays you can do everything just by click, right? Because you have a very nice system that is known as a graphical user interface, GUI. So look at this, how basically, and the DOS, as he mentioned, that everything you are just typing a command. If you want to move from one drive to another drive, you have to give the DOS command. You have to write in DOS prompt command. If you want to open a folder, you have to write a command. If you want to do something else, do copy and paste and delete, update, you have to just type a command for the DOS. But these DOS is changing over the time, over the period of year over year, and then it's coming with the shape, and it's making our life so comfortable. That's the Windows. Okay, look at here how DOS is basically improving. You see, there are several versions of the DOS, and with each new version having more capability. So every time some facilities, advantages are adding with the DOS, DOS is getting the new version, right? And DOS is not just one program. It is consists of a number of service or the routines, service routine. So as I said, routines, that means it's a number of, it's a service. Have you seen the services? Each and every task you are considered as a service. If you go to the My Computer, if you right click on the My Computer, you would be able to see the list of the services. Each and every service you are just considering as a number of program. Okay, all right. It consists of a number of service routine. Okay, and yeah, that is with the DOS, and these DOS actually. Students are disconnected and connecting again and again. And these DOS basically getting the new life when it is coming with the GUI, graphical user interface. So look at this, it is support a graphical user interface. That means when it is coming with the graphical user interface, that means you are looking the picture of the folder, you are looking the picture of the My Computer, you are looking all the icons for the application programs, right? You can see the pointers, you can move here and there, right? The position of the pointers. So lots of things are coming with that. Okay. And you see, there are two types of user command. One is internal and another one is external. So the command we are giving, it can be categorized in two ways according to the internal and external command. You can say yes.
Sir, what does the routines mean, sir? Service, I have understood service,
yes.
But what does
service routines? As I said, routine is a kind of process. So here routine, they are meaning like kind of process. What is the process? Process is a kind of like you can consider some instances of the instruction. Basically, in the context of computer science, we are saying process that when each and every instructions is getting the time from the microprocessor, it is becoming as a process. You know, to become, before becoming process, you know, this process has the other status and there is other name, program, then there are some others like steps even before becoming the process. So can you remember what did I say? When an instruction getting the time from the microprocessor for execution, that means that instruction become a process, and routine is a kind of process. Does it make sense?
Yes, sir. Now it's clear, sir.
Okay. All right. So now you can have a look the routines. So you have the two types of the routines. There's a routines loaded into the memory and routines that not loaded into the memory. So some routines, so always the internal routines are loaded into the memory, but external routines are not loaded into the memory. What does it mean? What can be the internal and external routines? What can be an example? Routines, that means some process that loaded into the memory, and some routines are not loaded into the memory. Routines that's not loaded into the memory, you are considering as a external routines. So all these external, let me tell you, all these external routines, these are from the outer part of the computer system. That means we are the external part of the computer system. Computers users are the external part of the computer system. Do you know that or not? Do you have that idea, guys? Yes. That as a user, what is our status? We are the external part, not the internal part. So we are trying to give some instruction, that instructions become a routine, and that is handled by the microprocessor. Okay, so that's why you are just getting two concepts with the operating system. So these are the, like what should I say, the idea or the concept that you can consider with the operating system. If someone tell you, okay, define the operating system, then what kind of information you can define with the operating system, or the history of the operating system. How does operating system works? If you look at the previous slide, I didn't go through that one. These are the operating system functions, right? What are the main functions of the operating system? All these four are the main major function. Whatever operating system you are considering, you cannot go beyond that. You have to satisfy these four functions, whatever kind of operating system you have. Is that clear? So you can just go through that one. I think we are very close to finish the chapter 3, and next slide we are going to have a look about the BIOS. What is the concept of the BIOS? Do you know what is BIOS? Anyone?
Yes, sir. Yes, sir.
And when we can see the application of the BIOS?
Starting the computer system.
Yes, absolutely right. When you are booting the computer, you can see computers getting some information, right? All these informations are coming from the ROM, read-only memory, which is known as a primary memory of a computer system. Sometimes you can say it is non-volatile memory, okay, not as like a RAM, as like a volatile memory. So look at these system routines stored in a ROM, and that are not destroyed when the power is off. Okay, and look at this BIOS, basic input output system. So when the computer is starting, definitely the ROM has some process or some steps that need to be verified whether all the basic input outputs programs are functioning appropriately or correctly or not. So that's need to be make sure at the very beginning of the starting of your system, and it performs all the I/O operation, not only checking the BIOS, it is also perform all peripherals operations like I/O operations for the computer. And routines are machine specific, like when the informations the instructions or whatever process you are saying coming from the ROM, you see the routines for the ROM for 8086 machine and routine for the ROM like 80486 machine, same? What do you think?
Sir.
Not the same. So that's why you are saying these kind of BIOS, it is not machine independent. It is machine dependent. So it is actually depending on the logical architecture of a computer system, and that's why you see they are saying different hardware configuration has its own BIOS routines. Is that clear? So when you are designing your machine will have your very specific routines for that one. Is that clear?
Yes, sir.
Okay, so it's not going to be, please make sure BIOS always machine dependable, not the machine independable. That's you have to understand. Okay, all right, and this is the ending for chapter 3. And as I told you, just like as I told you that anytime I can give you the quiz from chapter 3, but not up to covering this. If I'm taking the quiz today, definitely not covering the last few slides. Okay, but however, it is not a big deal because you are getting the lesson, right? So you should have some idea. Anyway, so now any questions from chapter 3 particularly before moving to the new chapter, chapter 4? Anyone?
Yes, sir. I have one question, sir.
Please.
Sir, although the processor can operate all data that are stored in memory, but
Sorry.
Sir, although the microprocessor can operate any kind of data that is stored in memory, but why
Secondary memory, microprocessor use the different level in the cache memory. Microprocessor use the resistors, but you should know that if you are saying that microprocessor using the resistors is a kind of memory, but why? I mean, how microprocessor? I mean, using these resistors. You know, the resistors, when the data is coming from the resistor, it is bit faster. When you are getting or accessing the data from the resistors, it is more faster than the other memories. And that's why you are also comparing with the cache memory. You see, you are saying cache memory is faster than the main memory, but slower than the CPU. Why? Because CPU using some kind of memory which is more faster than the both main memory and the cache memory.
Yes, sir.
Because resistors are the faster. That is the reason behind that. Okay. All right. Any other query? Any other query? All right then, guys. So I'm just taking you to the another new chapter. First of all, on chapter 2. This is Introduction to IBM PC Assembly Language. So basically, we are going to get inside the assembly language. So I'll just take you through the learning outcome. That so what kind of syntax you need to follow for writing the assembly programming statement. Look at these. They are saying assembly program, not case sensitive. You know the meaning of the case sensitive, right?
Yes,
Case sensitive, that means always you have to follow somewhere the uppercase, somewhere lowercase, somewhere lowercase, and then uppercase. So that sort of things. So there is no issue about the case sensitive. However, sometimes you are writing the uppercase just to make the differentiate in between the code and any other text that you are using in the program. So when you are writing the assembly programming code, you are writing in capital letter, just to know that, okay, these are the assembly code and these are the other statements or the content that is related with this program. Is that clear? But you are not going to say it is case sensitive, okay? And every statement is either an instruction or the assembler directive. So you are going to say that either you can consider the every statement of assembly programming you can consider it is an instruction or assembly directive. If it is an instruction, you are going to say that you need to convert it to the machine code. But if it is you are considering as an assembler directive, that means assembler directive always gives some guideline or some instruction, some command to the assembler to execute some particular job. That is the main responsibility of the assembler directive. Is that clear? That means if it is instruction you are considering as instruction, that means the instruction need to be converted or translated into the machine code. Okay, and who will do that? Assembler. But if it is assembler, if you are using assembler directive, that means assembler directive always keep the direction, give the order to whom? To the assembler to do some specific task. You see, such as allocating memory, it is a kind of assembler directive. Such as creating a procedure, that is also assembler directive. Okay, so these kind of things you are doing. We will see the application of it very soon in the next slide. So both instruction and directive have up to the 4 fields. This is important, you have to understand. So whenever you are using some directives or the instruction, it can carry up to maximum what? Maximum 4 fields, not more than that. It can be less than that, but not more than 4. Is that clear to everyone?
Yes, sir.
I can ask you during the maybe exam or the Bible. Up to how many fields can be used with the assembly code or instruction? You should come up with the answer. What are these? Look at here. This is the format, that how the fields are coming. You are saying up to the fields.
What was the question before?
What is that?
What was the question you?
Yes, I can ask the question about this topic that I am discussing right now.
You said a specific question.
I didn't say specific question. I said I can ask you that I may ask you that what are the maximum fields? How many maximum fields you can consider with the instruction and directives, assembly code instructions and directives? Are you going to write down the question? I can give you the guarantee that I'm not going to ask you the question in that way maybe, but it can be. But if you know the things, whatever, whichever my question pattern, it doesn't matter, you can answer. Am I right or wrong?
Yes, sir.
The understanding should be clear, right? So, every instruction can have the 4 fields. The first field is the name. The second field you are considering the opcode. You know the opcode?
Yes, sir.
Some instructions like addition, subtraction, move, exchange, division. These are the operation. We will see when particularly we are learning this operation, we will see many things about that. No worry, the time will come to us. Then operands, and then there is another one, comments. But make sure, as I said, maximum 4 field you can consider. It doesn't mean always you are going to consider 4 field. But most of the time we are going to be strict with the middle portion, like operand and operation. Okay, operation and operand. Most of the time we will work with these 2 fields. Is that clear? And comments, it is additional. Name, yes, when you are using some variable, you need to give some name. When you are using some resistors, you need to give the name. Make sense? But this is the general format of a assembly code or the instruction. Now we are going to have a look like the example of instruction. I'm saying assembly instruction. What is the example? This is the example. So look at this start. So what is the which field this one? This field operation, name, operand, or what do you think?
Name.
This is name, absolutely right. This is the name field. Then you have the operation field. Then you have the operand field, and then you have the comments field. That means comments always starting with this semicolon. Don't forget, right? In C, you are using double slash, right? Or the backslash. I think it is backslash, right? You are using double backslash for giving the comment in C or C++, right? Here you are giving the comments like using the semicolon in front of the comments. Okay, and as I said, most of the time we will be focused on these two, operations and operand. Okay, all right. Now look at see another example of the assembler directives. What kind of things you are considering as an assembler directive? As I said, assembler directives always giving the direction, giving the order to the assembler to perform or to execute some specific task. So what is the meaning of that? Look at this here. You are saying this is the operation and this is the name. So you are giving the name, the main, and this is operation proc. So proc is a kind of operation. So assembler directive, when you are writing this kind of assembler directive, assembler can understand what assembler need to do. Does it make sense? Is that clear? So we, by this instruction, assembler simply can say you are writing these two words in the program, in your program. Now what assembler will do? So assembler will create a procedure, and the name of that procedure is main. Is that clear? That means assembler directive giving a order to the assembler. So create a procedure and the procedure name will be main. Now you can say, okay, this is maybe Mr. X proc. So you are telling to the assembler, create a procedure. The name of that procedure will be Mr. X. Does it make sense? Now you can say the proc, it is the short form of the procedure. What is the procedure? That means some segment. You are just defining some segment, like you are writing a method, main function method in the C and C++ program, right? So main method, main function, it is the heart of the program, right? So all the other instructions and logics you are writing inside the main method. Am I right or wrong?
Right.
Similarly, when you are creating a main proc or procedure, that means it is going to be the main part of the assembly program, and that is creating by the assembler directive. They are giving some more detailed description. Please read it and try to understand that whether the meaning is correct, meaning is understandable by you or not. Is that clear to everyone?
Yes, sir. Clear, sir.
Sounds not good from everyone. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay, all right. So now we are going to have a look at the next field, like name field, right? We just learned about the instruction. Now this is a field like name field. In instruction, you are considering as a name field, like what times we have to give the name. And if we need to give the name, how can we give the name? How many characters will be in the name? What would be the syntax in the name, right? So that sort of things you are going to learn. You see, so the name used for the instruction level. So you can give the name for the instruction. You can give the name for the procedure. You can give the name for the variable. We saw we have given the name for the procedure, right? So how we can assign the name in assembly program? Definitely there should be a syntax. Some rules we definitely have to follow them. Okay, so look at this, and whenever you are assigning a name, that means you are allocating the memory. You see, when you are declaring a variable in C or C++, what you are doing? You are just assigning some part of the memory from the main memory, right? And here you are translate. You see, each and every name translates names into the memory address. So whatever name you are giving for the procedures or the instructions or the variable, every time that name is converted to the memory address. Okay, and then microprocessor communicate with that memory address to execute that function. Okay, all right. So now look at this. What are the rules you have to follow? So 1 to 31 character maximum you can use by giving the name. If you are giving a name, maximum 1 to 31 characters. What are the combination of the character? You can use the letter, you can use the digit, you can use some special characters. Let me repeat, when you are giving the name, you can combine 3 type of characters: the letter, number, and the number or digit, or the special characters. Now when you are using the special characters, there are some particular special characters, not every special characters. Look at this. What are the special characters? This is question mark, question symbol. This is period or the dot. This is at, this is underscore, and you can use the dollar sign, and you can use the modular sign or the percentage, right? So these are the particular special characters that you can consider with the name. But you have to make sure, if you are using the dot, dot must be started at the beginning of the name. So you have to have a look. If a period means what? This is a dot. If a period is used, it must be the first character of that name. So now if I write a name, say ABCD dot, is this the correct name or wrong name?
Name.
Sorry,
Wrong name.
But if I give a name like dot EFZS, is this correct or wrong?
Is this correct?
This is correct, because we are putting the dot at the beginning, right? That's what they are saying. But make sure, not begin with a digit. Name cannot begin with a digit. So if I say 2 ABCD, is this correct name?
Wrong.
It is wrong, because it is started with the digit or the number. But if I say EFZA is 2,
That's correct.
is correct, because number is coming at the end of the letter. Okay, now we are going to have some example, more example. Look at here. Example of legal names. Example of legal names. So these legal names, look at this counter. So what are the combination here? Character combination, letter and digit, right?
Yes, sir.
So if I put the 1 at the beginning of the C, is this going to be the correct?
No.
So digit coming at the end, right? Okay, so look at the second example. Do you think it's correct?
So correct.
Yes, because you are combining letter and
Special character.
special character, but we have just only special guideline for the dot, right? And what about the third example? Some underscore of digits. So you are combining what? How many types of characters here? Special characters and letter.
And later.
Okay, and here the fourth one, you see, is special character and digit. Is this correct? Legal?
Yes, sir.
Yes,
Correct.
sir.
Okay, it's correct. And how about the fifth one? What kind of characters you are combining for the name?
Letter and later.
Later and
Letter
special
and
character.
special character. How about the last one? Is this correct?
Yes, sir.
Yes, sir.
Why?
Special character
Because
and
period
later.
is of the beginning of the.
Absolutely right. Now we are going to see some illegal things. That means that is not correct. Let's have a look. 2 words. Why it is why it is there is a space that is not accepted by the assembler? Does it make sense? If you want to make it legal, what you have to do? Maybe you can use some special character, or you have to omit the space, right? 2 ABC. Is this correct?
No, sir.
Digit is coming at the very beginning, right?
Yes,
Digit is coming at the very beginning. Then the third one, is this correct?
No, sir, because
No,
the
sir.
dot is in middle.
Dot used in
Dot,
the
not,
middle
you
portion.
see, if it is dot, it must be at the beginning. So you and me, is this correct?
No, sir. It is not correct, sir.
Why?
We cannot use the AND operator for the.
Yes, we cannot use the ampersand, right? We cannot use, this is not the special character that is mentioned in the previous slide, right? So that is the things. So these are the things always we have to carry in our mind if you are giving some name for the procedures, for the variables, and for the instructions. Okay, I believe it will be okay when you are in the practice. Okay, any confusion from here?
No, sir.
Okay. All right, now we are going to see, look at the operation field. We finished the name field. Now we are going to see the operation field. So what we can learn from the operation field. So for the operation field, you see, you are just going to, each and every operation fields are going to have some symbolic operations code that is known as a opcode. Sometimes we can see move, exchange, add, subtraction, division. So these are the increment, decrement, shift, rotate. So these are the opcode. Does it make sense? So that's why they are saying here, often it's described the operations function. You think, for example, move, add, subtraction. So all these you are considering as a opcode. Again, in exam, maybe I can ask some questions. Okay, how opcode is different than the pseudo opcode? Pseudo opcode is coming next, no worry. So this is clear about the opcode. So each and every opcode you can consider as a operation field. Is that clear?
Yes, sir.
Okay, so what can be the opcode? Opcode can be like addition, subtraction, division, like this, move. So these are the opcode. Now look at
moving
this.
purpose.
Sorry?
Move means moving purpose.
Yes, move means you are shifting the value from source to the destination. Okay, that's why it is move. Okay, so the operation field contain a pseudo operation code as well. Now the question is, what kind of operation we can consider as a pseudo operation? You say pseudo opcode, you say not translated into the machine code, like as a director. You say proc, assembler, directive, right? So assembler directives you can consider as a pseudo opcode. Is that clear? So when you are declaring proc, this is actually kind of pseudo opcode operation used to create the procedure. So now you know that if it is opcode, opcodes need to convert into the machine code, right? Move, add, subtraction. But if it is pseudo opcode, it doesn't need to translate into the machine code. You see, not translated into the machine code. Pseudo opcode not translated into the machine code. It is always giving the direction to the assembler, like procedure, right? So assembler simply can understand what does it mean procedure. Just to create a procedure, right? And definitely you have to give the name for the procedure, and according to that assembler work. So it is the difference between the opcode and pseudo opcode. Is that clear to everyone? Is that clear?
Yes, sir.
Yes, sir.
Okay, all right. So if it is clear, that's fine. Now we then what is else? You know, in instruction we have seen how many field? Name field, operation field,
Operand
Operand
And
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 comment.
comments. So next, what we are expecting? Operand. Yes, let's see.
Operand.
Yes, so for the operand field, look at here, what we can do for the operand field. So you know the operand, right? Basically, if you have the operation, how operation will be executed unless until you have the data. So you are storing the data into the operand, and that is using by the operation. Look at here, operand field specifies the data. Each and every operand field specify the data that are to be acted, that are to be used on by the operation. So if I write an operation or the instruction like C equal A plus B, you know that you have the operation C equal A plus B, from where you can get the data for the A and for the B. Somewhere it should be stored, right? So these A, B and C you are considering as a operand. Am I right or wrong?
Sir.
Okay, so look at this. Instruction may have a 0 operand, 1 operand. Assembly instructions can have 0 operand. That means instruction can have without any operand. Maybe you are thinking, what kind of instructions then? What is the purpose? Right? We will see that one. Just wait for a moment. And then instruction can have 1 operand as well, and also the 2 operands. Like when you will have the 2 operands, then you should also keep in your brain, if it is 2, one will work as a destination, another one work as a source. So if I give you like add, this is operation, all will you agree with me? Add A, B. Am I right or wrong?
Yes, sir.
That means you are going to add 2 values, value of A and value of B. As I said, if there are 2 operands, that means the first operand is the destination operand. First operand means the left side operand. Okay, is that clear? Just give me a second, please. Say if I write an instruction, move AX BX, what does it mean? Can you read it, guys?
Yes, sir.
I'm writing move AX BX. That means you are going to shift. How many operand here?
2 operand.
2 operand, right? Okay.
Yes,
we are
sir.
saying which one is the first, AX or BX?
X.
So this one you are saying this is the first
Destination.
operand and this is the second operand, right? So this one, first operand, you are going to consider as a destination, and this one you are going to consider as a
Source.
source. Does it make sense?
Yes, sir.
Okay,
Yes, sir.
so now what does it actually mean? Actually that's mean if you are saying move AX BX, you are sending the value of BX, you are sending the value from the source to the destination. Is that clear to everyone?
Yes, sir.
Yes, sir.
Great. Okay, good. Now let me take you back to the point. Chapter 4. Yes. All right. Okay, now you can see the operand field, right? So you know, is there any confusion with the source and destination?
Sir.
First one you are considering as a
Destination.
and the second one you are considering as a
Source.
source. Good. Okay, now we will see that why we are saying that assembly programming instruction can be with 0, 1 and 2 operands. Look at here, NOP. NOP is a kind of instruction that you can use in the assembly code just to understand or to pass the message to the assembler. No operands does nothing. No operands does nothing. That means you can just, but we are not going to use that one for our purpose. When you are writing some complex or some many line of push, sometimes you have to use that one. Okay, all right. And when you can see like increment or decrement, say increment INCAX, DECAX. So how many operand you are using?
On.
One operand you are using. So you are increasing the value of AX. Is that clear? Is that clear to everyone?
Yes, sir.
Sir.
Okay. So now we know that how we can use the one operand with the operation. Okay. And now two operands. You see, add word, comma, 2. That means you are adding the value 2 with the value of word 1, and you are storing the result into the word 1. They are giving you the clear instruction here that what actually you are doing by writing this assembly code. So what we can see here only the application of the operand and the operation. Am I right? And this is the comments. I mean, they are giving the explanation. When you are using the same thing in the code, definitely you have to put the semicolon if you want to explain what is the meaning of this line of code. Is that clear to everyone?
Yes, sir.
Okay. So any confusion from this slide?
Sir, when there
Yeah.
is one operand, why do we add 1 to the contents of that operand?
Sorry, I didn't get you. Who is
When
talking?
there is one operand,
Yeah.
when there is one operand, why do we add 1 to the contents of that operand?
Why do we add? Because you see,
1.
yeah, because what is the operation you are using? The operation you are using increment, INC. INC AX, what does it mean? That AX value is going to be increment by 1 unless you are mentioning that how the value is going to be incremented by 2, by 3 or by 1. Sorry, by 4. If you are not mentioning that how the increment will be increased, by default it is incrementing by 1. Have you seen the for loop, the counter in the for loop? Like you are writing I equals 0, I less than n, I plus plus.
Yes, sir.
Yes, sir.
Is that clear? Did you understand? That means you are using increment. So this is increment in assembly language. You can also do the decrement as well. Then the value will be decremented, right? So there should be initial value for the operand, and from that initial value it is going to be decremented. Is that clear? Say if I write move AX 6, that means what you are doing, the instruction first of all move 6 into the AX, right? Then after that I'm writing instruction DEC AX. Then what will we do? Then times every times you are just going to decrementing. Does it make sense? The value will be decremented from the DX, because earlier the value of AX was 6. When it is executing the instruction DEC AX, that means it will be 5. Is that clear?
Yes, sir.
Okay. All right. So now I think this is going to be the last slide for
Sir,
this
in
class.
assembly language, I don't see any third bracket. I mean brackets. How can assembler understand that these lines of code will be executed?
You cannot see the
third bracket like another programming language.
yes. So that's why it is machine language. It has its own grammar, own structure.
How the assembler understand that these lines of code will be executed?
That's why you need to install the EMO 8086. Did you install the EMO 8086?
Yes, sir. I installed it.
Did you see the step by step that how it's moving?
Yes, sir. It's very tough language, I think.
It's very tough language. No,
I didn't understand anything.
When you are going to the chapter 6, it will be easier for you, right? Okay, you can apply the jump, you can apply the condition, you can apply the for loop, everything you can do in assembly language. We will see that one. Just you are learning the grammar, you are learning the syntax. Now on this slide you are going to see that how assembly program can recognize some number. Okay, look at this. Look at the first number on this slide. usually we can understand maybe this is binary number, right? Do you agree with me or not? We can simply understand that this is maybe the binary number, right?
Yes, sir.
But what you can see in the type, according to the assembler, it is decimal number. Okay, so now how assembler can understand it is binary number? If you are adding one B at the end of the 0 and 1, then assembler can understand it is binary number. Does it make sense?
Yes, sir.
Okay, now for the, look at this 64223. Simply we can understand it is decimal number, right?
Yes, sir.
Yes, assembler can also understand it is decimal number. But assembler can also recognize that it is decimal number if the number is ending with the another letter with the D. You see, look at here, 21843D. Assembler also gets it is decimal number. Now look at here, 1,234. Is this legal or illegal number? Assembler can understand it is illegal number because it's contain a non-digit character. It's contain a non-digit characters. And what about the hexa number? Look at the hexa number. So 1B4B is considering as a hexadecimal number. But look at the next one, 1B4D. We know this is a hexa number.
But we put decimal symbol.
But you see, it is illegal. Why? Because it is not ending with the hexadecimal symbol, that is H. Does it make sense?
Yes,
so these are the difference. These are the specific syntax that is using by the assembler. Look at here, FFF. Is this correct hexa number? No, it is illegal also. Because why? Because it is not starting with the 1. So every hexadecimal number should be started with the digit and ending with the letter H. Then it's going to be considered as a hexadecimal number by the assembler. Is that correct? Look at the last one. Is this correct hexa number?
Yes, sir.
Why? Because it start from digit.
Yes, it is starting from the digit and then ending with the hexa characters. I mean characters haze or the letter haze. Is that clear to everyone? Guys, are you listening to me?
Yes, sir. Yes, sir. Clear.
Okay, guys, I think I will finish with this slide, and next day we are going to continue